so let's start with a quick little overview of what we spoke about in the last lesson. We were doing a bit of vocab. So as we talk about circle geometry, that's the center point. And a rather important line is, that is a rather important line. That is a rather important line. Oh, wait, no, that's not good enough. Let's try again. And that is a rather important line. And I would like to know in the chat, what is the pink line, the yellow line, and the green line called? They all look kind of the same. They look like straight lines, but they have special names. So pink is the diameter. I agree. Pink is the diameter. And green is, it seems the people have spoken and said green is a tangent. I agree with that. And what about the yellow? Yes, the yellow is called a chord. Absolutely. Then what we also need to know about is sometimes we have, what is this line called? What's that line called? It is indeed called an arc. Yes, an arc. And so in the last lesson, one of the main ideas we dealt with was the idea that an arc can subtend an angle at the center, and an arc can also subtend an angle at the circumference. And I want to know, what is the relationship between the red angle and the green angle from the last lesson? Are they the same? Are they different? Oh, I love it, Kat. The red is double the green. And so in maths, what I'm going to say is, if that was x, this would be 2x, or it would be double. Yeah, so we looked at that. Something else I want to point out is that in the last lesson, I really focused on the idea of an arc subtending an angle, but it's also possible for a chord to subtend an angle. So some textbooks will say, if you have this thing here, some of them will say the arc AB subtends an angle at the center and at the circumference. Some textbooks will say the chord AB. It doesn't really make a big difference because they are both joined, but just to point out that you can use either the chord or the arc to subtend an angle. And subtending is a fancy word for saying the base on which you build the angle. And then the harder part of the last lesson was realizing that sometimes we get different types of shapes. So one way of subtending the angle at the center and the circumference actually looked a bit different. It looked almost like it had fallen over sideways, and yet that theorem was still valid. And so we said the relationship still holds. This is double the size of that one. And then the last shape that we dealt with was actually, excuse my dodgy drawings, was instead of focusing on this arc down here, if you focus on the longer arc, so what we call the major arc, it's possible to have an angle at the center that looks like that. So let me get some red. I think this was the toughest part of the last lesson. So that's the angle at the center, but then the angle at the circumference looks kind of like that. It's almost like it's bending over. And I think that was probably the hardest part of the last lesson, but the same thing is still applying. This is going to be, if that's 2x, that's going to be x. If that was 2x, that will be x. Basically, the red is double the size of the green. Give me a thumbs up if that makes sense to you if you were in the last lesson. If it's your first lesson today, obviously that will be a bit much. but you can have a quick look at the recording. Just want to see if we can remember that from the last lesson. Okay. Awesome. And again, if you're feeling unsure, just go back and watch the parts of the video that are most helpful. So this is called the angle. This is called so actually I'll do reasons at a later date. For now, I've made the decision to focus on just pictures. We'll learn the reasons in terms of the exact names later. Okay, so let us start with a warm-up question about circle geometry just generally. So here is your warm-up question for the day. What is the size of the missing angle? And the missing angle is going to be the yellow one here. It's going to be X. See if you can work out which option is the missing angle X. And ask yourself, what pieces of information might be relevant about this circle? Who would like to, if anybody's willing to share their thinking, who would like to share their thinking about this, how they got to the answer? I'm curious to know, and what ideas popped into your head that would help you. I see quite a few people are going the way of C. I'd love to know what thinking you used to get to the answer. Let's go to Letty. Letty, what did you think? How did you get there?
I think that the 40 angle is also equal to the other side, which is 40. So
okay, perfect. Name it. Before you go,
minus 40, then we get X.
Perfect. Okay. So Letty has noticed that there are two radii and they are equal, which gives us an isosceles triangle. So that's 40 and that's 40. Now we also know that there's a 90. And because this is a triangle, we know it adds to 180. So 180 minus 90 minus 40 gives us 50, which is C. So for Tekel, there's 3 different types of triangles. If they're all equal, it's called isosceles, equilateral. If 2 sides are equal, it's called a scalene triangle. Sorry, not scalene. Ugh. It's called isosceles. And what it means is that the base angles are equal, or the angles opposite the equal sides are equal. And then the third type of triangle would be like if they were all of a different length. Doesn't really look too good, but that's called a scalene. And it basically means like, let's do this. Like if they're all different length, all you know is that it adds up to 180. But all triangles add up to 180 automatically. Sweet. Okay. Well, let's test out some of our thinking from earlier from the revision. And we're going to do questions that are slightly harder. So let us try and do, okay, let's do number 9 and number 10. So let's do number 9 and 10. And you have to find me angle B and then angle C and then angle D. See if you can do that. Maybe make it a bit bigger if that helps. Now, so just the ones I've highlighted. Can you find me the missing angles? Okay, so a lot of people are saying that, and I agree. You can see that shape is pretty clear. 10 is a bit trickier though. Would anybody like to tell me how to do 10? Like what thinking they were using in order to get to 10's answer? Because it looks a bit like a lot more is going on. Like it feels a bit more complicated to me visually. Ofelo, would you be willing to share? Let's go. Pangwa. How's it going?
Good on you, sir. So,
Very
sir,
good.
with the angle D, sir, we can just pull D to the like center. No, not to the center, but in line with the center, sir. And then it will give us that D is half of 88. So D is 40 what? 42, 44.
40?
44 degrees is.
So that's great. And so you've noticed the shape. It's just pointing a different way. Hey, that's the key thing. It's like, it's you using that bit there.
Is.
Okay. I think that's most of it. Now, what about C? Do you have any ideas for C?
I think that C is half of D. So I think C is 22.
22. What's your reasoning or what's your thinking about that? Like, how did you get C?
Yeah. I don't know.
No, that's fine. So the reason I'm asking you is tricky, but thank you so much for D. I totally agree. And I'd love to hear if there's some other thoughts about how we find C. Ayabonga, would you be willing to share your thinking about how you got to C? Or maybe somebody can give us a tip that they used. I don't know how I would use the angle at the center, angle at the circumference one for C. I think I need something else. Is when I'm looking at it now. What other information do we have? So Irina said interior angles of the triangle. So there's no doubt, Irina, that there's a triangle there and it will add up to 180. The problem is I only see 88. And so how do I get C involved? Because C is sitting like up here. So there's angle C, and I just need to, yeah, Kevin, let's go to you. What do you think?
So I think those two lines on the side are radii.
Oh yes, I see it. Okay, how do you use that? How does that help us? I agree, they are radii. They're a bit hidden, eh? Yeah.
Those two lines are equal.
Okay, so those are equal. Yeah.
So if we can minus 88 by 180 and divide by 2, we'll get the answer.
Yo, that is good. Well done. So Kevin is saying we get 92, but now the problem is that 92 needs to be shared equally. And so I would get 46. So 46 here and 46 there. That's good. Yo. Because the thing is, those radii just hide away from us, don't they? And so that's what we want to build up this understanding. So I think we need a little bit more practice on this type of question. So I'm going to ask you to do number 11 and see how that goes. Sinosipo, why do we divide it by 2? That is a good question. What we do, Sinosipo, is there's 3 angles that are in this triangle. So there's the 88, which is here. There's this one over here, and there's this one over here. And what Kevin realized was the green lines are equal. They're radii. And so this is an isosceles triangle, which means that the A and B angles have to be equal. So we go 180 minus 88 to get 92, but the 92 needs to be shared equally into both angle OAB and OBA. So that's the divided by 2. Yeah, so the 44 for Techo, yeah, in this case, they're both in the playground, but it's a different part of the playground, basically. How are we doing on number 11? Yeah, so a lot about this section is just getting the visual awareness to interpret circles. That's my only goal with these 6 lessons, is to make you familiar with the shapes and the relationships between the different parts of the playground, to use the analogy I was using. What I like sometimes to do on my test paper is to ask myself here, I could say this arc over here, or if I wanted to, I could focus on this chord. Both would be fine. And they make an angle at the center of 98 degrees. And I think the angle at the circumference can be seen as E. So take a moment and ask yourself, if this is the angle at the circumference, sorry, this is the angle at the center, what is the angle at the circumference going to be? So the arc AC is making that angle at the center, which is 98. What angle would it be at the circumference? Letty, let's go to you.
So I want to ask a question.
Okay.
If we could use the rule that angles on a straight line are equal to 180, so the other side is going to be 180 minus 98, which is
102.
82.
Oh, sorry, 82. Yeah. Well spotted. Yes, that's 82.
And then
yes.
The other side of F is equals to F because it cuts in the middle.
So you're saying that these are both radii, so they should be equal. Am I understanding you right? Like
no.
These two angles, because okay.
I'm saying that F is equals to the other side of C.
I don't think so, because they would need to be parallel lines if you're going for the Z shape. So I don't see the parallel lines. So what I thought maybe you were saying was these are both radii, which they are. I agree with your 82.
Okay.
But yeah, I wouldn't agree with the Z shape. So I was thinking E would be half of 98. So if E is half of 98, it would just be 98 divided by 2, which is 40. What's that going to be? 45 for the 90 and 4, so 49. So E would be 49 degrees. So you could have got it like that, or you could have used radii, but I think 49 using the angle at the center is twice angle at circumference is probably the easier way. Now, what about F? What is F's answer going to be? Who would like to share their thinking with us? Yeah, Fatejo, what do you think?
Hello, sir.
Hey.
So when I was finding F, I said 180 minus 98, which is 82, and 82 divided by 2, which is 41. So F is 41.
And I agree with you. What information how did you know you could divide by 2? What did you notice?
It's an isosceles triangle, so the radii are equal.
Yeah, exactly right. That is perfect. Okay, so I think whilst we're not perfect at this yet, we definitely have understood how this theorem behaves and how it interacts with isosceles triangles and radii. Tebogo is asked to re-explain why E is 49. So Tebogo, the reason I got E as 49 is that if you imagine AC as the arc, that is the angle at the center. Okay. And then the angle at the circumference is going to be this one, using the same arc. And so the relationship, this is going to be the red one, this is going to be the green one, and so it should just be half of 98. It's just that it's sort of, they're sitting on top of each other, so it looks a bit trickier. Okay, before we go to our halftime break, I want to show you a new miraculous theorem related to circles. And you'll be asking yourself, how did I not know this? How did I get to this age in my life and not come across this fact? That's what I thought first time I saw it. So let me show you an example of this. Now I'm dragging this point around the circle, and what you notice is that the angle that is found at the circumference seems to stay the same. Who could try and put this into words to describe what's happening in this question? Who would like to put this into words? What does this mean? Luyolo.
Hi, sir. Can you hear me?
Loud and clear.
Sir?
Yeah.
Oh, sorry. So I think the degrees, it stays constant.
Okay, so the angle at the circumference stays constant. Okay, Loyola, watch this with me and see what you think of this. Watch, oh wait, let's go. What am I doing? Here we go. Now, if I do this, now watch that. Watch that. What do you think this theorem is telling us based on that points that I was moving there?
So I think it's telling us that if you move like the angle, it's gonna stay the same. But if you like resize the whole shape, it's gonna change.
Okay. Yep. That's what I was. So I would say I agree with most of what you said there. I just want to see if I can do a little drawing just to kind of focus it for you. So here's a circle. If I draw a line through the center of my circle, what type of line is that? Tell me in the chat what type of line you think that is. What's it called? Okay, it's called the diameter.
Diameter.
Perfect. Now, if I subtend an angle at the circumference using the diameter, I would get this angle over here. And what I think it's telling me is it's telling me that that's equal to 90. But for example, what that's also going to tell me is if I did this over here would also be 90. But the moment I don't have a diameter, the moment it's not a diameter, and that's what I think this is telling us here, the moment it's a chord, the angle at the circumference will no longer be 90. And so this is called an angle in the semicircle theorem because a diameter makes a semicircle. And so if you make an angle using the diameter as your base, if you subtend an angle of 90 using the diameter, then this theorem comes into play. Is that a question, or are you happy? All good.
Oh, sorry, sir. I am happy, sir.
Okay, let's do a little multiple choice question before we go to the okay, let's do this one. What is the size of the missing angle X? Using this new idea about circles you've just learned. Is it A? Is it B? Is it C? Is it D? I see some B's, I see some C's. Okay. Oh, there's some B's and C's. Okay, well, first of all, ask yourself, is this a diameter? I think it is. Then ask yourself, what is this angle? Oh, no, come on. What is this angle over here going to be equal to? Well, based on the theorem I did now, that would be 90. But I still haven't got x. And to get x, I need to go 180 minus 90 minus 50. So 180 minus 90 is 90. Minus 50 is 40. And so my answer would be that one over there. Would be 40. Yep.
So
thank you.
So what you're saying says that if an angle, how do I put it? So if we take an angle from the, if we subtend the diameter with the two radius, where the radius meet, will it always be 90 degrees, sir?
Okay, so so let's talk about that. So if you take the diameter and you have a diameter and you subtend an angle at the circumference, so these are actually not radii, these are chords. Radii would have to go from the middle, but if you subtend an angle, if you build an angle from the diameter to the circumference, that will always be 90. Yes, that's exactly what it means. You can take that to the bank. Yeah, let's do another one like this just to hone our skills. Okay, so it says here, what is the size of angle P in this circle? And then once you think about it and work it out, and then you can choose the option in the chat. Yeah. Let's see. So here's my diameter. I know it's a diameter. Then this angle up here is the one that's subtended at the circumference, which means this has to be 90. I know this one down here is 18. I've just taken it away. So I go 180 minus 90 minus 18, which gives me 72. And yeah, it's actually not a very difficult theorem. That's why I said, like, when I first saw this, I remember I was like, how do I not know this? But it's, if you draw it, you'll see it's definitely true. Loyolo, what is your question?
So can I ask, is there always like a 90-degree angle when it comes to the triangles in these circles?
Okay, so the theorem says, and we haven't done a proof today, right? So I'm just showing it to you visually, is if you have a diameter, okay, but you must have a diameter, then the angle that the diameter subtends at the circumference will always be 90. Let me show you with my little animation again. It's a little bit easier to show you with that. Let me see if I can bring it down here. Because it's not obvious why the diameter is so important. So if you look at this, you'll notice that it doesn't change. It stays fixed. But if I do that, if I move the chord.
Oh, yeah.
See, notice, and then boom. So it's quite helpful in terms of solving these types of problems. All right, people, we've been going for more than half an hour, or just for half an hour since we properly started the lesson. I think my brain feels like a break, and I'm sure yours does too. So let's take a brain break. So let me stand up. And I encourage you to stand up too and join me. And yeah, let's just...
Please turn on your cameras, guys. Let's see those lovely faces. Get on your feet.
The people of the land. Okay, so now step one is just going to be, we've been sitting for a while. What I want to do is I want you to start turning a little bit to your left. and then swing back to your right. And just rotate your body nice and gently so that you're stretching out your stomach muscles a bit. Kind of like you're trying to make a diameter eventually, or at least go one side of the circle to the other.
Come on, guys, your body will thank you. Liama and Masana, don't get FOMO.
Okay, step number 2 is going to be to put your arms out. Let's see if you can see me here. So put your arms out, make little circles. So small radius, and then slightly bigger radius, and then slightly bigger radius, and then, oh my goodness, these are big circles. There we go. Okay. That was good. Then we're going to do a nice stretch where we stretch our arms across like this. Okay. And then switch arms like that. And then shake it all out. Just go nice and floppy. Get nice and relaxed. And then last one, let's just roll the shoulders nice and small, nice and gently. Roll them back. And then roll them slightly more. Then reverse direction.
Doesn't that feel good, guys?
I must be honest, I'm feeling more and more human every second. And then, okay.
Reset to default settings.
Yeah. Oh, yeah, love it. Love it, love it, love it. Have a seat, have a seat.
Shout out to you guys.
Yeah, I definitely saw some good participation there, and it is awesome. So, second part of my brain break. I want you to try and make 24 using these 4 numbers. You have to use each number once, and you may only use plus, minus, times, and divide.
And Petava really doesn't like this game. She's like, oh no.
You know what though? So this game is super good for forcing you to think about times tables. And so it's kind of my sneaky way of making sure, in case your times table knowledge needs a bit of extra practice, I'm sneaking it in, even though we're doing a brain break.
Mr. S, can you please explain it again for the new students?
Okay, so I'll do the red one together with you. So I have to use all 4 of these numbers to make 24. And I've got a 3, a 3, a 6, and a 2. So if I go 6 times 2 plus 3 plus 3, unfortunately, I'm not winning because I get 12 plus 3 is 15 is 18. But at least I've used all 4 numbers. Maybe if I go 6 times 3 plus 2 plus 3. Oh, well, I'm not there yet. I get 23. Who can help me get 24? Aha. Okay, so Issa has said 6 times 3 is 18 plus 2 times 3. And so Bodmas says this gets done first, so that's 18, and that's 6. And I see a lot of you agree. So the first one's answer is 6 times 3 plus 2 times 3. And that's how it works. So see if you can do the blue one. Okay. So 8 minus 2 is 6. I agree that's true. But if you go times 3 minus 2, then that would be 3 minus 2 is 1. So I don't think you would get to 24 that way. So Naledi is absolutely correct that 8 times 3 is 24. But Naledi, you still have to use up the other 2 numbers. Now, how can you use up the other 2 numbers and still stay on 24? Noisy has said 3 times 3 plus 7 plus 8. Okay, but Noisy, you don't have 7 or 8. You only have 3, 3, 8, and 2. So Naledi has helped us a lot. We've got to 24, but we need to use up the 3 and the 2 somehow. Aha, Rafense. I think you might be onto something. And Paul, same thing. Yes, you times this. That makes sense to me. So you use up the 8 and 3 times 3 minus 2, and the brackets make you do it first. So you basically get that, which is 24. That is good. Well done.
Nicely done, guys.
Blue is a lot harder, and we'll just keep playing this game for a while just to kind of get our brains used to this idea. But don't worry, we won't do it forever. Okay.
Oh,
Yeah, the feelings. But this is the thing. It's like tough love. You may not like it at first, but sometimes you grow to love it. So we're not going to give up on it yet. But I hear you that it's not everyone's cup of tea. Okay. Brain break over. Let us return to the thing that we were talking about. Okay, let's see. Here's another multiple choice question. Can you find me the size of angle CAB? What is the size of angle CAB? So that is the diameter, which means that must be 90, which means that must be 180 minus 90 minus 48, which is going to be 42, which is D. Yeah. Okay. So this theorem is not nearly as complicated as the first one I showed you. And it does look to me like you guys are doing well. This is often called the angle in a semicircle theorem. And so that is that. Okay, let's go to something a little bit more detailed. I want you to try and do for me, I want you to find A and B in angle A, and I also want you to find me A, B, and C in the second question. See if you can do those two using what you've learned so far today. So as I look at the chat, I can see that people are recognizing A is 90. And then because all three have to add up to 180, this has to be 35, which I agree with. So that's those two questions done. For B, it gets a bit more interesting. It looks like there's more going on. Just to clarify, 62 is just this part over here, and 32 is just that part over there. So just so that we are clear on that, because I know it can look a bit vague. Maybe somebody could share some tips as to how they would, which one would they do first? I guess A is kind of the more obviously, yeah, for Tejo, let's go to you. What would you do?
Okay, so I started with B.
With B?
I said, yes.
What did you get for angle B?
The answer for B, I got 58.
How did you get 58?
I said 180 minus 90 minus 32.
Okay, so you saw that this was 90 because it's the diameter makes that angle. And so you said 180 minus 90 minus 32. And what did you get?
58.
I agree. Awesome. Thank you very much. So 58 is that one. In the chat, I think I can see lots of people are saying that A is 90 because it's also an angle at the circumference that's being subtended by the diameter. The more interesting one is C. Well, maybe more interesting, but how do we get C? Okay. Aratile, Nozi. So A will be 90, yes. Yes, Nozi. So C is going to be 180 minus 90 minus 62, which is going to be 28 degrees. That looks good to me. Any questions or comments? Then I want everyone to try and do C. See if you can find A, B, D, E, a whole bunch of them in C. So Usupile, you can't say it's a line, can't we say C is equal to 38? We can't, because this angle over here, no, we can't. So the only thing we know is we know that that will be 90 and, oh, let me do it. Oh, what's this? So like, we know this will be 90 because that's using this one. We know this will be 90. And then what we have to do is we have to use the fact that triangles add up to 180 to help us. Pleasure, Mr. Pile. Would anybody like to share their answers for C? Let's go to Letty. Letty, what do you think we need to do here?
Okay. For A, I know that the whole thing equals to 90 degrees. So I said 90 minus 57.
Yep. And what did you get?
I got 35. No, 33.
33. Okay, awesome. I agree. So we know that A is 33. Fantastic, Letty. So if we get A, I was thinking maybe the next one we could get would be B. Does anybody have any ideas? Leteta, let's go to you. What do you think about finding B?
I think B is 33 degrees because of the angle. Because of the size. Sir?
Yeah, what did you say?
I think B is 33 degrees because of the angle, the handle, the arms.
I agree.
Cool.
Leteta, I think it's just a little bit of an audio feedback issue there, but what Leteta is saying is that it's 33, and I agree. The reason I was thinking, and we might have differed, I couldn't quite hear clearly, is that both these green arms are radii. And because they're radii, these two are equal, which means these two angles will be equal. Now, it's not the only way of doing it, but there's another way to do it, but I just spotted that way myself. So I would say that B is equal to 33. Now, if we look at the next one, who would like to do the next one? What's the next one after B? What can we do? Paul, let's go to you.
So because we can see that from angle C to the center of the circle is the same as from the center of the circle to angle B, we can therefore say that angle B is equals to angle C, and therefore angle C is 33 degrees.
So I agree with you that these are both radii. So let's have a quick look here. So what you're saying is that this is a radii and this is a radii. But now if that is 57, I was thinking, shouldn't this one over here be the same as that one over there?
Yeah, it should. Oh, so C is 57 then. Yeah.
Perfect. I agree. So C is 50, 57. Awesome. Thank you, Paul. Now, the last two we need to do, and people could have got these in other ways, is D and E. What do we get for that? Fatejo, let's go to you.
So I have a question, right?
Okay.
So can't the radii for the triangle for CD and 57 be the line from D to 57 and the one from C to 57?
Okay, so I think we are saying the same thing. Are you saying that's 57 there and this is 57 here?
No, I'm saying the line opposite that one, right?
Yes.
Isn't
the green one or the blue one? What are you talking about? The green or the blue?
The blue one. And the one
is equal.
The blue one on the right hand side and the blue one on the left hand side. The one that's not shaded.
Yes. Okay.
So, So on the triangle that we're working with now, the side that you didn't shade.
Yes.
Right. Isn't that no, the other one?
Oh yeah. Okay.
Yes.
What do you mean? Yeah.
Yes.
What about that one? Yeah.
So I'm asking, isn't that green line the one you just shaded now, and the blue one opposite it the radii?
Only the blue ones are the radii. So only the blue and this one over here are radii. The green and the red one are chords in the circle. So they're not all. Okay, good question though. Thank you. So D is going to be 180 minus 57 minus 57 because there's two 57s here. And so we get 114. So we get 64 degrees. Was it 60? 66. Sorry, I'm doing that in my head. So 66. So this is 66. And then what is E going to be? Paul, let's go to you.
Oh, so I actually have a question, not the answer for E yet.
Okay, so that's fine. Go ahead.
The question is that, so the angles of the chords, will they always be equal?
Well, the angles of which?
So, like for example, 57 and C, or let's look at the next example, so at D, will A and E and D and C always be equal?
Okay. A, these two will always be equal because these radii are equal. Yeah. Okay. And then this one and this one will always be equal as well, but they won't be the same thing necessarily. So if you look at, like, if you pull out that triangle, right, the one looks a bit like that, and then the other one looks a bit bigger. So the angles won't be the same, but the radii will create two types of isosceles triangles. Does that make sense?
Yeah, it does. So.
Okay, perfect. Good question. Let's finish with this question then, because I think this is the last one for today. So let's do that, and then we're going to call it a day. Let's find A, B, C, E, and D. And once we've done that, we can call it a day for today.
Go ahead, guys. Stay with us.
I know this is tough. Hard here. This is E. This is D. Yeah, Blessing, let's go to you. What's your question, Blessing?
No, I don't have a question, but an answer.
Oh, lovely. Let's do it.
So D and E are straight line.
Okay.
So which means D and E are equal to 180. And now we know the value of D.
Aha. So let me just see if I'm understanding you correctly. You went 180 minus 72. And
no,
then
66.
Which one are you on? So Blessing, say again, yeah? Okay. I think there's a bit of a sound issue there, Blessing, so don't worry. We can always come back to you. What I thought I was hearing was if I go 180 minus 72, but maybe I see a couple of other hands are coming up. So let's go to Kat.
Sir, I said 180 minus 72 to get B first.
Okay. Oh, I see what you mean. Oh, I understand now maybe what was being said before. So we get B because it's on a straight line.
Yes.
And so that's 108. Oh, I get it, what would be trying to be said there.
And then since the triangle is an isosceles, I subtracted 108 from 180 and then I divided the answer by 2.
Yes. So you went, once you got B was 108, you meant 180 minus 108 and you got 72, and then you divided it by 2 and you got 36.
Yes.
So you're saying A was 36.
Yes.
Fantastic. And what about E? What do you think E is going to be? Yeah. So A and E are both going to be 36. Fantastic. Thank you. What about D and C? Any ideas for that one?
And then after that, I said 90 degrees minus 36 degrees.
Oh, yes, because you used the idea that this must be 90. And so D, well done. Well done. That was a good spot. So we get 54 degrees for D. And what about C?
We have a hand from Peter from Mr. S.
Okay, let's go to Fatekel.
Okay, so
what do you think
for B and C, I used the idea for saying 180 minus 72, which gave me 108, and I divided by 2. I divided by 2 to get 54. So I got 54 for D and C because it's an isosceles triangle, so the radii are equal.
That's kind of where my brain went to initially. And it just shows you that we all kind of got to the same answer, but we can sometimes use it slightly different way. And you notice the answers stay the same. Okay, everyone, we have done a lot of work today, and I just wanted to kind of revise the main ideas. We dealt with this theorem that deals with, we call it the angle in a semicircle, and how we can use that theorem to solve for unknown angles in a circle. Often, it seems to go together with the radii of a circle. So we use that, and we use the idea of a sum of the angles in a triangle adding up to 180. That for me was the main focus. Obviously, we did the other theorem that the angle at the center is twice the angle at the circumference. That is also something we've worked on this week. But I think we've done a lot of stuff, and I think it's now time for us all to declare the evening over. Yeah, important, good idea. That's the benefit of having a recorded lesson. And you don't always have to watch the whole lesson. Maybe you just want to watch the piece that you want to refresh. And I would highly encourage you to watch watch through. Level, can you put the link to the quiz in the chat? That would be awesome. Oh, Rafense, that is such a nice comment. Thank you.